we're going to be putting on this number line include 4/6, 4/4, 2/2, 4/8, 2/8, and 3/3. Go ahead and list those fractions somewhere around your number line so we have them in our notebook. Draw a blank number line because we're going to be talking about where these fractions go. Alright, first things we need to look at is what our endpoints are going to be. What's going to be my first endpoint on the left? Lucy? 0. Definitely going to be 0 to start with. Now to figure out my other endpoint, I need to think, are any of these fractions larger than 1? Are any of these fractions larger than 1? Azalea?
The 2/8 fraction is bigger than 1 because 8 is larger than 1 because 1 is just 1.
So 2/8 is bigger than 1 whole?
No.
No. I need to find, are any of these fractions going to be bigger than 1? Dominic, what do you think?
2/2.
It's bigger than 1 whole? Okay, that's not what I'm asking. I'm not asking, is it exactly 1 whole? I want to know, is any of these fractions larger than 1 whole? Easton?
None of them are 1 whole because the highest they go to is 1 whole because 4/4 is 1 whole, 2/2 is 1 whole, and 3/6 are 1 whole. And nothing else is bigger than those 4.
Can someone give me an example of a fraction that is bigger than 1 whole? I completely agree with Easton. None of those fractions are bigger than 1 whole, but what would be an example of something larger than 1? Miranda?
1/2.
1/2 is not bigger than 1 whole. Right? 2 wholes is bigger than 1 whole. Brinley?
6/3.
6/3. If we think of all those third pieces, it would be more than 1 whole. Very good. Eliana?
3/2.
3/2 would be bigger than 1 whole. Good. All right, now Easton said that some of these fractions are equal to 1 whole. Annabella, which one of those fractions is equal to 1 whole? If you were listening, Easton told you. Autumn, do you remember? I don't have 2 wholes. 2/2 is equal to 1 whole, right? If I have 1/2 and another half, Annabella, and I smush them together, I have the whole thing. Let's go ahead and put that down. I'm going to stack it right on top of my 1 whole because I know on a number line, if it is stacked, it must be equal. Nope, we're not doing this on a whiteboard, Bailey. We're doing it in our notebook. Emma, can you give me another fraction that is equal to 1 whole? 3/3. I'm just going to keep stacking. Annabella, can you give me another fraction? 4/4. Now, the fractions that I have left, I have 4/6, 2/8, and 4/8. Those are different denominators. I got 6 and I got 8. Remember, if I'm putting the fractions all on the same number line, I'm going to start with the smallest denominator. Which one of those has the smallest denominator? 4/6. Is 6 an even number? Yes. Does that mean we can have a midway point? Yes. Let's put a midway point, please. How many spaces are going to go on either side of my midway point? Grace? 3. 3 and 3 is going to give me a total of 6. Double check that you have partitioned your line into 6. Brayden, do I count tick marks or spaces? Spaces. Do not count those tick marks. We're counting spaces. Azalea, where is 4, 6 going to go?
Right here.
Better yet,
On the.
come put a dot. Just watch your arm, because if your arm touches it, it's going to make a dot. Nope. Marker. Or 6. Can you put a dot on the tick mark? Perfect. All right, we got 4, 6 labeled. Done. Can I use my 6 to label my 8?
Yes.
Can I just start labeling 8?
No.
No. Bailey, today, please. I don't understand why you can't get your notebook out. We need now to make 8. We don't have 8. We have 6. So I need to now put 8 on my number line. I'm going to do it in a different color just to make it a little easier for you to see. First, is 8 an even number?
Yeah.
So what does that mean?
It goes in the middle.
We have a midway point already. I don't need to redraw it. If I want to trace over it, I can. There's my midway point for my 8. It's the exact same spot. However, this is where it gets a little tricky. How many tick marks do I, or not tick marks, how many spaces do I need on either side if I am making 8? I'm making 8. Got it? How many? 4. 4 and 4 gives me a total of 8. Try to ignore the lines that you have. We're going to put them all on the same number line, but try to ignore. Maybe make them extra long, something that you can really tell. Okay, that's about even-ish. I'm checking the spaces in between my red line. It's very tricky, I know. Dominic said, hey, couldn't we just draw another number line? The answer is yes. You are more than willing and capable to draw another number line. That's fine. It gets very tricky with all these lines, I know. Let's start with 4 8. Where is that going to go? Where is 4 8 going to go? Bailey?
In the midway point.
How do you know that?
Because in the midway point, it's normally 1/2 and 4 halves. And then, sorry. 4 8 is a equivalent fraction to 1/2 because 8 is an equal number and part of 8 is 4.
Yes. Bailey said, hey, I know that 4 8 is equal to 1/2. Put your notebook down. So it makes sense that they're at the same midway point. What about 2 8s? Where's that going to go? Brayden, put your notebook down. Where is 2 8s going to go? Liana?
At the second red.
Yeah. Is 2 8 bigger or smaller than 4/8? Is 2/8 bigger or smaller than 4/8? Arwen?
It is smaller, but I want to say something else.
Okay.
2 is half of 4, so 2, if you go from 0 to 4/8, the midway point would be 2.
Yeah, very nice. Definitely. How do you know 2/8 is smaller than 4/8? Prove it to me.
Because it's behind 4/8. If it's not in front and it was above 4/8, it would have been like 4/6 or 1 whole.
Arwen's using words like behind and in front of. She's imagining this number line like a track, like a racetrack. If we are imagining 0 as the start line and 1 is the finish line, each space is where you are on that racetrack. We would say then 2/8 is in last place. Who's in first place on this race?
4/8.
4/8 is not in first place.
Oh, 4/6.
4/6 is in first place because the distance from 0, or our start line, all the way to 4/6 is farther than 4/8. Yes, ma'am.
Like a few days ago when I was in the classroom, I figured out that the bigger the number is, the smaller it is. And the lower the number is, the bigger it is.
The bigger the pieces are. Yeah.
So the bigger the denominator, the smaller the number.
Pieces. Yeah. Pieces.
Would actually the 4/4 and the 6 be so then 2 halves have 1?
Fair enough.
They're already at the end.
Fair enough. I guess we could say they were the first place. But if we're measuring who's still on the racetrack, then we might say 4/6 is the farthest. Fair enough. I like it. Good stuff. All right, we're going to move on to our next blank page, please. That's fine. Just give it a subtitle. All right, we're working with different models to compare fractions. So our title is going to be, what are all the models that I can use to compare fractions with different denominators? Pause your writing. Look at me. I said different denominators. I think you guys can tell me between 2/8, 4/8, which one is bigger. Because it's the same denominator. You see what I'm saying? The same denominator, I think, is pretty easy peasy for you guys. We're talking about ones with different denominators.
Like 4/8 and 1/2.
Like 4/8 or 4/6. Those have different denominators. It's a little bit trickier to figure out who is farther. All right, go ahead and keep writing your title. That's what we're going to be talking about today. We've learned a couple of different models. What are some models that we have learned when we're comparing? Think back to Math Choice Board. When I ask you, would you rather, what do you normally draw? Or that's what I'm asking you. What are those models? What are those drawings that you usually use? Remember? Yeah, we use 2 bar models. How are they arranged on the page? Is one like way over here and one over here?
No.
How do we draw our bar models? Because we're very picky about how we draw them, right? Why do we draw them stacked?
One can be small, one can be big.
Yes. So one way that we can compare is with stacked bar models. So fraction number 1 goes on top, and then fraction number 2 goes on bottom. Bryce brings up a very good point. The reason we use stack is because now we know 100% those bars are equal to start with. We've learned we cannot compare things when one is giant and one is small. We have to compare them being the same size to begin with. If Azalea and I are trying to compare who can eat a chocolate bar fastest, it's not fair if I have a fun size and she has a king size.
They have to
They're
be the
two
same
different
brand.
holes. You have to start with the same size hole. That is my favorite model because I think it's the easiest to draw. But we have other ones. What's another model you could use?
Your favorite one
Lucy, you can use circle models.
is
That's going to be 2 circles. So this would be fraction number 1 and then fraction number 2. I think circle models are very hard to compare on. I would not use them to compare. You might be able to use them to show a fraction, but I don't think they're helpful to compare.
you could stack them.
We could stack them, but it's hard to stack 2 circles.
So stack this.
It gets a little complicated. That's not the only strategy we've learned, though. What else have we learned? Brayden?
Number one.
What about our number line? Describe it to me. What does it look like when you're using a number line?
Looks like a number on different parts of
Is it 1 number line or 2 number line?
it. It can be one or however many use.
Yes. So we could do 2 number lines.
Do we have to make this one big?
Just like what Bryce was saying with our bars, we tend to stack our number lines for the same reason. We want to make sure they're the exact same length. If you're using a number line, 2 is usually the easier option. We're not putting them side by side, we're putting them stacked so that we can make sure they are the exact same length. So on this version, fraction number 1 would go on that first one, and then fraction number 2 would go on that one. I think another really hard number line to use is what we've been doing in our number talks, which is 1 number line partitioned into lots of different fractions. On that number line, fraction 1 and 2 are on it. That's the one we've been doing in our morning work, where we have lots of different denominators, and we're putting it all on 1 number line. These are the 4 models that we've used and that we've learned about. I want you to rank them by what is easiest for you to use. Number 1 is the strategy you like the best. Number 4 is the strategy you like the worst. Go ahead and put your numbers next to which models you like or dislike. Leo, Tom, and Sarah were trying to figure out who ran the farthest during PE. Leo said, I ran 2/4 of the track. Tom replied, I ran farther than you because I ran 4/8 of a mile. Sarah said, Tom, you didn't run farther than Leo. You ran the same distance. Who's correct?
Next year.
Mila, what is the very first thing you need to do? Because it's not yell out an answer that you think you need. Brenda? Answer sentence. Write one. Should be a really short one because it's a really short question. Very late today. You're spending a lot of time not writing down math. What's my answer sentence going to be? Very, very short today. Corwin? Blank is correct. That's it. We can add a because. I like adding a because. The reason why is I want to be convinced. Yellow is the best. Yellow is the best because it's the brightest color available. I'm a little bit more convinced now. I need some convincing power. Prove it to me, whoever you pick is correct. Raise your hand if you picked bar models as your number one. That's the strategy I want you to use. Raise your hand if you picked number lines, 2 number lines, as your number one. That's the strategy I want you to use. Raise your hand if you picked circle models as your number one. Raise your hand if you picked 1 number line as your number one. That's the strategy I want you to use. So know what strategy you've got. My number one is bar model. That's what I'm going to do. If your strategy is a number line, you're going to do the exact same thing, just on the number line version. What am I comparing in this problem? What is it that I'm comparing? Donut? Puppies? Autumn, what am I comparing in this problem? Yeah, who ran the farthest in PE? We had 2 kids. Which 2 kids are running? Easton?
Leo and Tom.
Leo and Tom are running. What's Sarah doing?
Just
What is Sarah doing? She's not running. Really?
He's just trying to figure out who ran the farthest.
Yeah, she's trying to keep these boys straight. Kudos to you boys, you ran, but you don't even know who won. Sarah's trying to be almost like a referee. Who's winning here? So I know I need to represent Leo. Let's go ahead and make a model for Leo. Again, I'm using stacked bars.
I'm using numbers.
You can use whatever makes your brain happy. Either way, unless you're doing 1 number line, it should be stacked. We're stacking to make sure that we're talking about the same whole.
We do.
So if you're using number line, you can use 2.
But we can use 1.
You can use 1 if you want to.
Well, I go to.
What am I going to partition my Leo bar into? What am I going to partition it up into, Scarlett?
2, 4,
How do I do that? I do what? Okay, as many lines as I want. How many lines? That's what I'm asking. How many spaces do I need? How do I partition that? How many spaces, if I'm making Leo's bar or number line, how many spaces I need? Okay?
You need 4 spaces and 3 lines.
I need 4 spaces. That denominator, 2/4, tells me how many total spaces I need. Go ahead and make that happen. Now, Dominic, I could color in any one of those boxes, right? Yep.
No, wait, yes.
Yes, I can. However, when I'm comparing, it makes it a little
left.
it makes it easier if we start left to right. I can color in any one that I want. That's fine.
But we're comparing.
But I'm comparing and I want to make it easy for my brain. So now that numerator tells me 2, I'm going to shade in 2. I'm going to put in a little L so I know that is Leo. What about my other friend, Tom?
You went 40.
What do I need to partition Tom's bar into? Right? 8. Why? So why not 4? And 8 is what? The denominator tells me the total number of pieces. I have to look at that denominator. Is 8 an even number? Yes, that means I can have a middle. Azalea, can I shade in any piece that I want?
No, you have to say you can, but only when you go to the middle.
I can shade in whatever piece I want. However, it does make it a little easier if I just start at the beginning and go across. Oh, I'm going to put a T for Tom. So I know
They're
that's Tom.
both equal, so
So, who is correct? We really only have 2 people giving opinions. Leo just announced what he ran. Tom is saying I ran further. Sarah is saying, no, you guys ran the same. Who is correct here? Brinley?
Sarah,
Sarah. How do you know?
because whenever I put all the fractions on my number line, both 2/4 and 4/8 were at the same tick mark.
Beautiful. Community 2 signal use number line. That should be what you write. They show up at the same tick mark. What about my bar model? What's going to be my response there? Because I don't have tick marks, really. I have bars. So how do I know Sarah's correct on my bars? Ethan?
you can prove that she is correct on the bars that they equal up to the same amount because 1/4 is equal to 2/8 and there are actually 4/8. So 4/8 plus 4/8 actually could equal 2/4. So they're equivalent.
So we can say they're equivalent. They take up the same amount of space.
And also, Lewis is also correct because he did 1, 2, 4.
Yeah, Leo wasn't really making an opinion. He was kind of just stating what he did. If you have bars, you need to be telling me, hey, they took up the same amount of space. Go ahead and finish your answer sentence with some words.